Hi, my name is Muhammad Faris Amir bin Suhaimi. My supervisor is Madam Siti Rahmah binti Shamsuri. Today, I will present my final year project, which is effect of heat treatment to the morphology of titanium dioxide powder synthesis via hydrolysis. First, we will start with the introduction. Titanium dioxide or TiO2 is widely known for its excellent photocatalytic activity. For most photocatalytic applications, it is desirable to have a large surface area of TiO2 coating. Three main structures of TiO2 is rutile, anatase, and brochite. Various techniques have been used to fabricate TiO2 coating for photocatalysts such as CVD, PVD, deep coating, and salt gel method. In this project, I will use the hydrolysis process. Hydrolysis process is a simple method which not require a high temperature. The involved reaction of titanium sulfate and water will obtain the TiO2 powder. Next is the problem statement. First, TiO2 undergoes a phase transformation from anatase structure to rutile structure at higher temperature. Second, the changes in crystal structure and crystallite cell of TiO2 powders reduce the photocatalytic property of coating. Our objective is to synthesize the TiO2 powders material using hydrolysis process. Second, to review the effect of heat treatments at different temperatures on the morphology of the TiO2 powders. The scope is will be use hydrolysis process to synthesize the TiO2 powders. Next, heat treatment at three different temperatures, which is 200 degrees Celsius, 300 degrees Celsius, and 400 degrees Celsius. The characterization will be using XRD and then will be reviewed by SEM analysis and FTIR. After the introduction, we will move to the literature review. The purpose of literature review is to gain more knowledge about the existing research. So this is the literature review that I have been used for my final year project. Next, we move to the methodology part. The first part of the methodology is the preparation of the TiO2 powder. This is the flowchart of my preparation of TiO2 powder. The first one is stir on hot plate for 80 degrees Celsius for 8 hours. And then the TiOSO4 plus with distilled water undergo hydrolysis process. After that, white precipitate is formed. After the white precipitate is formed, wash with distilled water several times. After that, dry in oven at 120 degrees for 10 hours. After the drying process, we will crush the TiO2 powder by using the laboratory mortar and pestle. The details of preparation of TiO2 powder is here. The figure above shows the hydrolysis process of TiOSO4 with distilled water on a hot plate for 80 degrees Celsius in 8 hours. In the early phase of hydrolysis, the solution consists of TiOSO4 with distilled water is the white solution, but after a few minutes, the white solution turns into a transparent solution. After that, after a few minutes of the form of the transparent solution, the transparent solution turns back into white solution like the early phase. The countdown of 8 hours stir is begin after the transparent solution turns into the white solution like the early phase. During the 8 hours of stir, it is important to make sure the temperature is always 80 degrees. To make sure this happens, I will always check the solution temperature with the thermometer. After 8 hours of stir, white precipitate was formed, and then the white precipitate undergoes cleaning process which is washed with distilled water for 5 days. After the cleaning process for 5 days, the white precipitate will undergo drying process. The drying process is in the oven at 120 degrees Celsius for 10 hours. After undergoes the drying process, next we will crush the TiO2 powders that we get from the drying process with the laboratory mortar and pestle. This is for the next step of our methodology. After the crushing process, now we move to the calcination and characterization of TiO2 powder. First is the calcination. Calcination is the heat treatment that we use in this project. The calcination will be at 3 different temperatures, which is 200 degrees Celsius, 300 degrees Celsius, and 400 degrees Celsius. Therefore, we will make a 4 sample, which is asynthesis, and with the 3 different temperatures that we have been done. Next is the characterization. The characterization that will be used is scanning electron microscope, SEM. Next, X-ray diffractometer, XRD, and Fourier transform infrared spectroscopy, which is FTIR. The next part of the methodology will be the results and discussion. XRD, SEM, and FTIR will be used for morphology of the TiO2. In this part, the XRD analysis will be discussed by the data that have been obtained in the lab. Meanwhile, characterization and result by SEM and FTIR will be based on a critical review of various previous data. The first one is the XRD analysis. The raw data of this XRD analysis have been obtained from the lab, which is from my sample that I have been worked on the methodology part. Figure 1 shows the XRD pattern of TiO2 with different calcination temperature with the asynthesis TiO2. The next figure is about the crystallite size of TiO2 powder with different calcination temperature. For the crystallite size, the Scherrer equation was used to obtain the crystallite structure value. The most intense peak in each of the calcination temperature was selected to determine the peak and FHWM value for the Scherrer equation on each calcination TiO2 temperature. The XRD pattern shows the characteristic of another phase of TiO2. The crystallite size, which has been shown in the table, shows the difference between each of the TiO2 sample in the terms of crystallite size. The crystallite size does change and increase when the calcination temperature is increased. However, the changes are not significant. This shows that calcination does improve the crystallinity and the crystallite size of TiO2 powder. Next is the SEM analysis. The SEM analysis is to describe the morphology of TiO2. Based on the research by Toyiba in 2016, the different temperature does not give significant effect in terms of size particle. This can be seen in the figure that have been provided. The SEM image of TiO2 powder calcined at different temperature by Toyiba in 2016. This review is the proof and consistent with the previous result in the XRD analysis. Based on research of Aroyimbo in 2018, he carried out 2 samples of titanium dioxide and calcined with 400 degrees Celsius and 700 degrees Celsius respectively. The TiO2 of calcined at 400 degrees Celsius shows that surface particles which are much more homogeneous. Meanwhile, the TiO2 of calcined at 700 degrees Celsius experience significant increasing in terms of particle size. The detail can be seen in the figure of SEM of titanium dioxide particle at 400 degrees Celsius and 700 degrees Celsius that have been provided by Aroyimbo in 2018. From both work, calcination at 400 degrees Celsius shows a similarities in terms of particle distribution. It also shows a denser microstructure compared at lower temperature. Salim in 2011 stated that the TiO2 that undergoes heat treatment for 400 degrees Celsius and above will face difficulty in result in a lack of ability to build up coating during impact of the coating process. Next is the FTIR analysis. This figure shows the FTIR spectra of TiO2 nanoparticle by Horty in 2019. FTIR is used to scale the presence of TiO2 nanoparticles. Based on research by Horty in 2019, 6 samples of TiO2 had been used. Asynthesis, calcined at 300 degrees Celsius, calcined at 400 degrees Celsius, calcium at 500 degrees Celsius and calcium at 600 degrees Celsius. Absorption band in range of 550 to 800 is a proof of the presence of the TiO2. Broad peak is observed from 3,800 cm to 3,200 cm is because the range of water molecule and TiO2 are interact with each other. From the figure, we can see absorption intensity is decreased along with the increasing of calcination temperature. Now, we come to the last part of our presentation, which is conclusion. First, the calcium TiO2 does give a better crystallinity rather than the asynthesis TiO2. Next, higher calcination temperature increase the crystalline size, but will be reduce the porosity of TiO2 particle. Next, calcination temperature affect the phase of TiO2. From the temperature, it can change the phase of TiO2 from anatase to rutile or both. The last one, low calcination temperature will retain the anatase phase of TiO2. That's all from me. Thank you.